All right, guys, here we are for the second part of the notes here. And we'll start off with proof of the sine law, okay, or the law of sines. The way we're going to do this is we're going to recall that the area of any triangle is equal to 1/2 AB sine C, which is also equal to 1/2 AC sine what? What, guys? B. And that's also equal to 1/2 BC sine A. Okay? So, I always do that. I'm going to label this triangle. That's angle A, that's angle B, that's angle C. So this is side A, side B, and this is side C. Okay. So if these are all equal, right? If these are all expressions for the area of this triangle, then I can set these all equal, right? So what that means is that, let's write this out, 1/2 AB sine C is equal to 1/2 AC sine B, and that's equal to 1/2 BC sine A. All right? If we see that, basically we want to work our way into an expression with law of sines. So first thing I can do, the 1/2s can go away, right? So now, for a while we don't have any denominators, we can just say AB sine C, is equal to AC sine B, which is equal to BC sine A. Okay, now what I'm going to do with this expression is I'm going to divide everything by ABC. Okay, that's okay to do, right? Because we've got equality throughout. So we can divide by every part of the equation by the same number, right? None of these are 0 because they're side lengths. So if we do that, maybe you're going to see what's going to happen, right? Well, if I take the first part and I divide this by, let's just write it, by ABC, we see these are going to cancel. If I divide this by ABC, we see the A and the C are going to cancel. And if I divide this by ABC, the BCs will cancel. So look what just happened. We got that sine C over C is equal to sine B over B, which is equal to sine A over A. Okay, and if that's true, then we could write the other way. We could flip it and put the sides in the numerator. So A over sine A is equal to B over sine B, which is equal to C over sine C. Done. So, nice little proof using the area formula of a triangle, writing it in 3 different ways, setting it equal, and then manipulating the parts. Okay, I think the rest of this is examples. So, yeah, we'll go through these as best we can. Length AB and angle A are given. Use a third side of length 7 to draw a triangle. Okay, so this could be ambiguous case, right? So if I label the stuff that I know, it's already labeled, so we know that, but we don't know the length. But I guess in theory, this third side could be in different places, right? And actually, probably the best way to do it, AB, oh yeah, AB is given, okay. So what we want to check, this is called the ambiguous case, right? Because we know 2 sides, so we know this side AB, and we know this other side, right? But we don't really know where it could be. It could be like this, could be like this, could be like this, could be way out here, right? The thing is, we can't put that side here because if we put that there, well, it's just a single case. It's SAS. All right, so I think this is getting you to think about certain possibilities. So if it's SSA, and I should write on this, the 7's here, you could have multiple triangles. If it's SAS, and I'll just draw it here, so this is A, this is B, and we know this is 7, and that angle is 30.1 degrees. Well, there's only one triangle, right? There's only one triangle. It's going to connect B to there. So this case is, I want to make that all the same color. So let's do it this way. Let's make it all red. So for SAS, you have one triangle. Okay, this is a key difference. So let's highlight that. You have multiple for SSA. Potentially. All right. So there it is, right? Talking about the ambiguous case. So some things that we need to remember to actually figure out how to solve this. Well, in a triangle, right? All the interior angles have to add to 180. That's the first thing. No triangle can have two obtuse angles, because if so, those two would add to be bigger than 180, and that can't happen. The sine function has a range of -1 to 1. Okay, so this is really saying, right, let's get the blue back. The opposite over the hypotenuse has to be between -1 and 1. And really, for us in these situations, when we're doing word problems or whatever, it's just going to be, it can't be bigger than 1. So this is saying the opposite can never be bigger than the hypotenuse, which makes sense. And then fourth one, if the sine of theta is equal to a positive decimal less than 1, right, then theta can lie in the first quadrant or the second quadrant. All right, so what that's saying is if you have a sine value that's positive, right, that can happen anywhere in quadrant 1 or quadrant 2. Okay? So let's look at an example now. Solve a triangle ABC where A is 16, B is 10, and angle A is 70. So the way I like to do these is I like to draw the known angle in the bottom left corner. Okay, so I'm going to say this A is 70 degrees. Okay, and therefore the side A, so I'm going to draw it maybe like this. That is 16. And I'm going to call this B, so that's 10. So I like to have my unknown side as the base. But whatever way works for you is fine. But this is the way I like to set it up, right? So the unknown side is on the bottom. Okay, so what we could do is we could use law of sines, right? And we could say that 16 over sine 70 is equal to 10 over sine, let's see if that's 10 there. This has to be angle B. Okay, so if I work that out, give me a second to work that out, guys. I have the calculator here, so that means 10 sine 70. 10 sine 70 over 16. And then let me take the sine inverse. So, yeah, the way we solve for this, right, is if we cross multiply, we'd say 16 sine B equals 10 sine 70. Okay, so B is going to equal 10 sine 70 over 16, and then of course I didn't give myself enough room, so oops, I just want to get this part. To undo the sine function, we've got to take the sine inverse. Okay, so that I have to get from here. Trig sine inverse of 0.587308. That is 35.9. Let's call it 9697. So B is 35.97 degrees. Okay, that would be this angle here. If that's the case, then the other option, right? So let's draw that out. That's 35. That means it's kind of a small angle, right? So it's like that. This is 70. This is 35.97. This is 10. This is 16. Well, to get this top angle here, right, we can take 180 minus these two. So that's 110, hopefully, minus 35.97 is 74.03. So that's 74.03 degrees. And we could use sine law again to solve. So this would be side C. That means that C is equal to C is equal to 10 sine 74.03 degrees over, let's make that 16. You guys can see what happens if I try and do too much in my head. 16 sine 70 over sine 70. Okay, how am I getting that, right? So how am I getting this equation? Well, I'm saying 16 over 70, 16 over sine 70, excuse me. So that part, 16 over sine 70, 16 over sine 70 is equal to C over sine 74.03, right? So this over this is equal to C over that, and I'm just moving that sine 74.3 over. Okay, so if we crank that out, that's going to be, let's see, 16 sine 74.03 divided by sine 70. Sine 70. That's going to be 16.4. And if I look at this triangle, it makes sense. Okay, smallest angle, smallest side, bigger angle, bigger side, biggest angle, biggest side. Okay, so this is one triangle. Maybe I should, yeah, let's make that a little bit cleaner. So I should write this all out, but I don't want to make the video super long. So that's one solution, right? Here's the thing. When we got this answer here, right, there's actually another angle that B could be. Okay, so if I draw this out and if I use orange, well, 35.97 is there. So the sine of that angle would actually equal the sine of this other angle over here. Okay, so that angle could be something else. I'm gonna use, let's use green. So B could also equal 180 minus 35.97. 35.97. So that's 144.03. 144.03 degrees. All right. Now, thankfully, look at this. That angle can't happen, right? Because if I've got 144.3 and I add 70 to it, well, I've already got an angle, or yeah, I've got a sum bigger than 180, so can't happen. So in this case, this is the only answer. This is the only triangle that works. Okay? Let's stop there, and then I'll give you a shortcut for how you can look this up without having to work all that out. Okay, because there is a shortcut. So we'll look at these, and then we'll just talk about, when to use which rule, and got a couple more examples there. Okay, so I'm going to stop this video here, and we'll pick it up soon with the next couple